Hello, I'm Abigail Rubinstein, and today we will be joined by Shaul Shulman, the founder of SafeFields Technologies. Hello,
Hi.
Shaul. How are you doing today?
Good, thanks. Thank you.
So, would you like to tell me a little bit about yourself and your company?
Okay, so about myself, I'm an engineer. I was started my actually, my engineering journey, let's say, as a today, what you call. So I went to study in university before the army in Ben Gurion, and um, then I was lucky enough to be recruited into the unit, which is now it's kind of allowed to call it by its name, 81, and it's very interesting and very advanced technological unit where I also met my co-founder of SafeFields, Oded Einat, who was actually my first boss.
Very
So yeah, and then I was there about 7 years, and then I worked at Texas Instruments, and then Intel, and then another company, and then we founded SafeFields.
Very nice. Would you like to tell me a bit about the company's founding story?
Yeah, very interesting story. Um, so as I said, Oded was my first boss in the army, and we kept in touch since it was about 25 years ago. Um, since we kept in touch, and just for coffee. And one day, about 4 years ago, we were having coffee, and Oded was telling me about the fact that engineers, officers in the army, in the technological unit, they are refusing to give to receive the company cars they get. I mean, like army cars that is given to officers from a certain rank as a kind of as a bonus to use for the private life, and they refused to take few cars because they were hybrid cars. Well, I think it was Hyundai Ioniq back then, and why? Because they were concerned with the radiation. Yeah, and then the other thing they told me that he had an idea how to deal with it, which is doing active cancellation. And I thought it's really really cool idea um, because it's also an out of the box solution, and we both know the technological background of solving such a problem. I'll maybe touch upon that a bit later, but I kind of immediately understood that it's the only way to actually fix this problem is to doing active cancellation. Active cancellation is like the headphones that you have where you produce the inverse noise or the inverse signal, and that's how you kind of electronically can reduce noise, or in this case, radiation from cars. And I thought it was a really cool idea because the market, like let's call it, of electrified cars is moving from some niche, which maybe some few people are interested in, or now to, of course, in recent years, big boost, and it's going to be very soon the future. All the cars are going to be electrified, either hybrid or electric. So it's going to be like a public health issue that's going to touch everyone, and so seeming a lot of interest, and I thought it was a great idea, and then that's how we founded the company. Yeah.
Tell me a bit about the application process of putting these devices into vehicles and how it can affect the people who buy it, the customers.
Few words before about how we got to the point where we're already selling products. So first, I think it's important for the public, I guess, to understand what is that radiation that we're talking about. There's a lot of confusion about it. Also, the word radiation is a little bit confusing because radiation can mean lots of things, from nuclear radiation to everything, but radio waves. But what we're talking about is actually the magnetic fields, and this is very similar to the radiation or the fields that are produced from power lines. And this type of effect is relatively known in the public. So people who live near, let's say, a power line that they visibly can see, or maybe they have a big transformer near the room, they are aware, and they may call technician to measure. But very few people are aware the same you have in a car, because a car is also a high power delivery system, and there are high current flowing, and you are exposed to this magnetic field. And the problem is, and this is the technological challenge comes here, is that it's very hard to, using conventional methods, to prevent this. So the easiest way to prevent this is just, don't get near the power line, or don't get near. So just, take some distance. But in the car, you cannot do that. The car is very, very dense, and there is no really a lot of place where you can route the cables, and it's not possible. And the other conventional, let's say, method to deal with such radiation or such electromagnetic fields it's called shielding. So big metallic plates, or in this case, because it's low frequency magnetic fields, you need a very special material which has like a permeability, which is like a magnetic conductance type, and then you have to. So it's very, very hard to do it in the car. Basically, it means that there is no real solution to do it in the car. So what we came up with is the system that does it is actively. So what we have is there are some sensors in the car that sense the magnetic field. There is a signal processing unit, like a small box, which can be anywhere in the car, in a convenient location, as a matter where, and from it goes an antenna, which then transmits the antiphase or the reverse noise, and then it cancels this radiation. And we are now working in two markets in parallel. One is with the vehicle manufacturers, to be able to enable them to integrate this technology right into the car when it's produced. And for the cars that are already on the market, we have also what is called the B2C, or the consumer part of business, where we are already installing on existing cars. So today you can go and call our phone number and get your car fitted with the system. And it's about 2-3 hours. We hope it'll be less in the future. Process where we install this in the car, and you can, the family can drive safely and not worry about any potential health effects of this radiation.
Beautiful. And for your product, when you put it into a car, does it take up a lot of space? Like, how big is it? Where can you put it in a car?
Yeah, so usually it doesn't take any space, any usable space. It's about this big, so very small. It's like people who are listening is maybe think about like a very big iPhone, like a very big let's say cell phone, maybe a little bit more. And we find a place for it in the car where it's not usable. For example, where where there's a spare tire is, or where there are tools for changing of things, like under the hood, where things like that, we're not taking up any space from the usable space. And the sensors are very, very narrow. It's basically wires going, so it's not visible at all. We do put, if the customer wants, some small on the dashboard, some indication of that system is working. Just the person can see that everything's fine, and it's actually canceling the field. So kind of a user interface or feedback button.
I saw on your website that a lot of manufacturers don't really incorporate EMF radiation into their product, or consider it or its effect on customers. So why do you think this is the case?
Well, okay, so I would slightly, maybe rephrase it, that they do consider, but not as much as I think the public would like to at this stage. And actually, the reports that are coming out, and there was one big European Union report, and recently another report from the German Federal research center for radiation. They all state this fact that manufacturers should do more. They do try to meet some minimal standards. Usually they have their internal standards. Usually these have to do, with making sure that like medical implants cannot get out of their warranted environment in terms of magnetic fields or things like that. But obviously not doing enough, and the reason is because there's still not enough public awareness for this and public pressure, and this whole electrification is actually a new thing. So they are mostly focused. They are mostly focused on the burning issues, and this goes down in priority. And another thing is it's very, very hard to do. One of the reasons why it's very hard to design for EMF reduction is that you cannot really predict it. It's very hard to simulate. It is a parasitic emissions, and really you don't see it. You cannot measure it until the full car is assembled. And when the full car is assembled, it's already too late to use the conventional methods. That's why our solution is so attractive to vehicle manufacturers, because we can retrofit. So it can be applied when the vehicle is done, is ready.
All right. So hypothetically, if you were in place of the World Health Organization, what steps would you guys implement in order to prevent further exposure?
Well, I think the World Health Organization already has done its part in a way that they actually have put a lot of emphasis on the issue of magnetic fields from power lines, and I have on my desk like a 500-page book from the World Health Organization for extremely low magnetic fields, where they summarize all the research. Actually, they classify this type of radiation, or this type of fields, as 2B. It's like it's not 2. It's a digit 2, and the letter B is the classification of possibly carcinogenic. So it can cause cancer in some probability because of childhood leukemia studies. So the knowledge is there. What is, I think, lacking is more that the authorities in different countries take up this and bring it more forward to forefront of the first knowledge of the public of this, so the public can make aware decisions. Today, it's very hard to know if you're buying a new car, whether it's a hybrid or electric, or even a regular car. Sometimes they can have issues too. Is there any magnetic fields? Where are they? Because it's not visible. Unlike in the case of power lines, where you see it, you can visibly, where a transformer is, where your cable is. But here you don't know. So you get in the car, you have no idea. And actually, the first thing I would do, the first thing I think the public would benefit a lot is the grading of EMF and more transparency. And this is not so simple to do, actually. Measuring this has been an issue, and only recently there came out a European standard how to measure EMF in car, which also is, some other scientists already have some, suggestions or like some criticism or some topic, just saying this is very hard. But in any case, that's the process, and China already started it. Today in China, it's kind of maybe surprising / ironic to some that it is China who is leading the charge in protecting people from radiation, and not any other country. So they already have, as part of their NCAP, which is new car assessment program, like you have the crash test, the Euro NCAP that the people here, especially in Israel, know. They have a green car assessment program, and they also measure for EMF, and they publish the grade. So any Chinese consumer for any car made in China can go to the website and see what's the EMF level. So I think to summarize, it's each country's health authorities should start making more notice of this and start caring for their public, especially when the authorities are today basically forcing the population to go electric. So many countries today have this 30-30 initiative or whatever the year initiative, where there is a requirement to at some point to only sell electrified cars.
So that it will make people need to consider the EMF radiations as electric cars are becoming more popular within public society. Would you like to remind me, how many years has SafeFields technology been around for?
Mm-hmm. Okay, so as I said previously, we founded the company in 2021, so about 4 years ago. Mm-hmm. And it took us some time to develop the technology. We had the proof of concept. About after a year, we had a proof of concept, but it took us time to develop a product. We're already selling in Israel for a couple of months, and we'll be expanding about hopefully end of this year to another countries. Mm-hmm. And we are already working with some manufacturers. So yeah, it's been 4 years in total, but last year I would say we're already in the product phase.
Beautiful. And where do you guys plan on shipping to, or like marketing to in the future?
Naturally, I think there are two. So there are two natural, let's say, targets. One is where the awareness is maybe, or the public sensitivity to this issue is higher, which is some countries in Europe, or most countries in Western Europe, and also U.S. because it's a big market, and also there's a lot of public awareness and a lot of electrified cars. Mm-hmm. So I think we'll start that. We actually get a lot of interest from China as well, so we'll see, but it's more maybe difficult market for us. Yeah.
Very interesting. And with the look to the future, how do you guys see yourselves in 5-10 years and the state of your company?
Oh, it's a very interesting question. So our logo, like the sub headline says, enabling safe EV future. So we envision that our technology is incorporated in quite a large number of cars already made. The way we see the transition is that hopefully we can also sell a lot of aftermarket, but the purpose of the aftermarket, I should say, is the installation to the consumer after this is like the professional term, is when the car is already on the market and you install some add on it. So our aftermarket business, one of these purposes is that to encourage the automakers to incorporate it already. And this has been true for many things, like one example that I remember very well was the reverse radar, mm-hmm. which young people maybe don't even remember that there ever has been such thing, that you would go to, you would need, if you wanted this beep beep, when you go reverse and you want to park your car in reverse, you need to go like to Auto Depot to install it. And took some time until it became, and many other, let's say, gadgets, they started as a aftermarket and then became add-on. So that's what we see. We see transition, and eventually in 5 years we can say we will have our technology incorporated in many vehicles. And we also in parallel will be looking to another areas we have a very, very strong technological team, and we may do other things in the area.
What is the impact of radiation on consumers, and what does it look like?
Yeah, so basically, like I said before, An electrified car, whether it's hybrid or electric, is like a small uh, mm, power station and very high currents and very high power with very high currents running very, very close to the passengers. And usually, many times, it's also the back seat where the kids are sitting very close. We've seen levels, not just we, but also the reports that are coming out, like the European Union report and the recent report from the Federal Bureau of Radiation Protection in Germany, are recording many hundreds of pracoids, while in Israel the recommendation is to not exceed 4 milligauss from power lines and transformers, etc. So, especially kids and people who are sitting in the car where there is a local spot of radiation peaks, which can be orders of magnitude higher than what the WHO recommends as a safe level.
Well, thank you so much for joining us today.
Yes, thanks for having me. Thank you.